Hey friends, I got some pretty interesting stuff to share with you. I've been working on this crazy project, but you're not interested in robots or crazy AI, not the cool kind of AI, not the stupid chat bots. If you're into artificial life, if you're into, why bugs are interesting and why animals are interesting and why life on this earth is so freaking weird. So let's talk about embodied intelligence. So you've seen robots on YouTube and TikTok that can do flips and they can dance and they can do boxing and they're fighting people, and it's ridiculous looking, and they look really funny, especially when they fall down the stairs. Well, there's a reason they're falling down the stairs, and there's also a reason they're not in your kitchen right now making you an omelet or in your laundry room folding your clothes. And that's because they're using a concept called reinforcement learning. I mean, reinforcement learning does work. It works really well, and that's why Atlas can do all those cool flips, and you're seeing a lot of those interesting tricks coming from humanoid robots. But the problem with that is, as soon as the environment changes a little bit, that really cool move doesn't really translate anymore. And that's why if you see a robot brush its arm against a person that wasn't expecting to be there, it might fall down, flip out, do all those crazy things, because with reinforcement learning, you're not actually preparing the robot for the real world, you're preparing it for a very specific scenario. So enter active inference, or what I like to just call regular old embodied intelligence. So that just requires a change of perspective in how you actually build a brain. So I like to use the chessboard because we can kind of have a little bit of spatial awareness for our brain, right? So the king here is going to be an idea, a state of being for myself as an organism. Could also be the state of being for a bacteria or anything else, right? So when it comes to states of being, and you can call hunger a state of being, you could call uncomfortable, my leg hurts, any kind of state of being that you need to change, we can represent with the king here. So we like to call those states of beings just simply states, right? So here's a state. I'm hungry. Now, how can you affect this state? Well, the only thing that can affect this state are things around you that directly impact it. So we can say that there's a person standing behind a counter, there's the smell of a hamburger, there's some people walking through the door, and there's a horse-drawn carriage going by in the distance. That horse-drawn carriage also has a brother-in-law who, they've had a fight, right? We're making a ridiculous scenario here. So what are the things that actually impact my state of being hungry? Well, it's probably the smell of food. We'll call this one the smell of food, and we'll call this one the person serving me the food, right? So my hunger is directly impacted by these very few states in the universe. Those states that directly impact me and my hunger are what we call a very fancy term called a Markov blanket. It really encapsulates how you can build a machine that is essentially isolated from the rest of the universe, just like we are. Now, the way that we interact with the universe is through several different mechanisms, right? So we've got our senses. We've got sight, hearing, most important for the hamburger, a smell. We can also touch things. We can also taste things. That hamburger is going to taste really good when I eat it. So I have my normal senses, including how I feel, the entire state of my body. All of that feeds into the idea of being hungry. The universe's information is coming into my state, right? Now, it's no good for just the information to go in one direction. I need to change the universe so that it satisfies my state, right? So my state of hungriness needs to go down. I need to eat that hamburger. So I can take actions. I can walk. I can do other things like I can talk to people. I can take action in this universe through actions, right? If you're a single-celled creature, maybe you have a little tail that you can wiggle, and your only sense is a sense of smell. That's enough. That's enough to be successful for billions of years, looking at all of the bacteria. Now, the reason this is important for building a robot brain is to think from inside of the blanket. The only thing that matters are the things that directly impact the senses that I have to change the state here, right? So my actions, I can walk up in front of the person who's going to give me the hamburger, then my hand can reach out and I can eat the hamburger, and now it changes the state of my hunger, right? Now, some of that sounds pretty obvious, right? Well, yeah, but it's a lot different than the way we normally program computers. Usually, we do if this, then that, right? That's the normal way of programming a computer, and we're taught that, if you've ever taken a computer science class or even just computers in the library in high school, you've learned a little bit about how computers work. Well, they don't usually work in terms of this Markov blanket idea. If I'm going to build a system that works this way, I have to first visualize from inside what is the information I want to bring from the outside to the in, and then what is the action that I can take from the inside out to change the universe to fit my expectations. Now that's a really important word, expectations. What does that mean? It means predicting the future. I need to be able to predict the future in order to accomplish most goals, right? So over billions of years of evolution, organisms on this planet have gotten better and better and better at predicting the future. That's why we have these big brains. They're for one reason only, that's to predict the future. And part of predicting the future is being able to communicate with other people. If I'm walking down the road, then I'm pretty sure when I put my foot on this solid piece of concrete that it's not going to sink down and make me trip over. Well, sometimes things do change and you do trip, but for the most part, we're pretty darn good at predicting the future. So, when we're thinking of our Markov blanket and we're thinking about different ways of building a robot brain, we really want to think in these particular terms, right? Now, when you're thinking in terms of being inside of this closed off space, you start programming your robot differently. Now, if you think about that reinforcement learning idea where you've got these flipping robots, you've got robots that can do karate and all this other stuff, they have had someone input that information into their brains through that reinforcement learning process. That breaks this idea of the Markov blanket that every organism has to obey. And that's why it takes millions and millions of cycles sometimes to teach a robot these things. Now they can learn it really fast because computers are fast, but that's not like what an organism can do. A spider walking along the forest floor here is dealing with an extremely complex environment, and by and large, that spider can get around without too much trouble. It comes up to some new tree that it's never seen before. It can still climb the tree. It can still build a web. Every single web in this forest right now with all of these spiders are completely different. And it's absolutely amazing. Now, none of our robots are anywhere near as complex as that fly that just blew by or these spiders that are building these amazing webs. So that's my goal. I want to be able to build a robot brain using these concepts from the inside out and make it faithful to the way organisms work on this planet. Now, there's a lot of different scientific terms that we have to start using in order to describe how to do these things in computer science and all that. But I think the most interesting part is actually just building the brain itself. I'm going to be simulating it inside of the computer, and then my main goal is to build a robot that I can put on the forest floor out here and have it explore and get lost all on its own without any supervision. And it's going to learn on its own. From the moment that I turn it on, it learns how to walk, it learns how to be a part of this universe, and then maybe achieve some goals that I can set for it, right? Now, one of the ways that you have to program a robot like this is you can't say, okay, I want you to go left. It's not a remote control anymore, right? It has to want to do things. You have to kind of give it a sense of pain, unfortunately, right? This gets into the idea of, do robots have rights at a certain point? Because in order to exist in this universe, these senses need to tell us when things are dangerous, when things are inappropriate, for example. Those are things that you actually have to program into the computer that is running inside of this Markov blanket. Now, it's very tricky, and I've been spending months on this problem, and there's a lot of very smart people doing this also in the scientific community, but I'm doing it as an artist and as a musician because I think it's just freaking amazing. And the things I've gotten my little simulated robots to do have been really, really cool, and that's what I want to share with you. So let's go take a look. Okay, here's the system that I've been building. We've got a way of simulating the universe inside of the open source game engine called Godot. Now, this engine is capable of doing physics and 3D visualization. So this is actually the viewpoint of the robot that I'm simulating in the world right now. I also created a dashboard for looking at all the different parts of the brain so we can really dig into what each part's really doing and how it works, and as it builds new knowledge of its world and tries to solve problems, and also how these individual components work so I can debug them, fix them, get them to work according to the principles of active inference, and really just be functional in a way that's useful for this experiment that I'm running. Over here on the right, we're looking at the brain itself, right? So we learned about how the universe comes into the Markov blanket through our sensors, right? So our organisms always have a list of sensors. We have modules that constitute the different types of states and the different types of loops that we need to run to achieve a certain objective or directive or policy. And then we have the actions that we can take on the right hand side here, and those are our motor outputs or actions, right? It's been very exciting to build a brain like this because A, it really does work, and B, it really just gets your brain thinking in a different way. So this entire project is going to be open source so that all of us can share in this very interesting experiment and try new things. So I'm going to be releasing all of my diary entries leading up to today, and as they come out, you're going to see a story of frustration and hard choices and going down pathways that really, really didn't work. But the whole point here is to persevere and stay true to the ideas of active inference and really try to discover new ways of programming robots and agents that can act in the world very similar to life does on this planet. It's not easy, and you'll see me fall into all kinds of traps, like violating my own principles without knowing it, and dealing with those AI coding agents when they go off the rails and decide to do their own thing, which is outside of normal design principles and patterns. So if you've made it this far, I think you're probably interested in this kind of topic, in how life works, how brains work, and how we can use computers to create new and exciting robots and things that can act in our world to help us out and make our lives more interesting and better somehow. So I look forward to seeing you in the next video, and let's see where this project takes us. Okay, and one last thing I'd like to add is this xaq-ai project is sponsored by Bon Jovi Media and Technology, the acoustics company that I've been working with for almost 30 years now. That's where all this gray comes from. But we've been doing aviation, marine, automotive, medical applications, gaming, you name it. We've been working with those sound systems, inventing new ideas, new software, new hardware, doing projects that I've been really, really proud of and have been pretty game changing. So you can visit bonjoviacoustics.com or one of our other websites and get in contact with us and talk about sound and implementation of technology in your products. So go check them out. All right, see you in the next video.